Okay, now let us look at few simple examples to determine the Hurwitz polynomials. Okay, we will see mainly 4 problems in this class. Okay, so the problem will be given like even in the exams. Check whether the following polynomials are Hurwitz or not. Okay, very important problem. You can expect 5 marks in the exams. Okay, what is this first one? First polynomial is given as s power 4 plus 4s cube plus 3s plus 2, right? So we need to determine whether this is Hurwitz or not. So if you observe here, first of all you just go through the properties of this Hurwitz polynomial. What is the first one? All the coefficients in the polynomial should be positive, and if any term is missing between higher degree to lower degree, first of all it should not miss. If it is missing, and if that missed degree is of even, all other even degrees should also be missed. If it is odd, all other odd terms should also be missed. Okay, let us check with this first property now. Here the highest degree is 4, lowest degree is 0, that is s power 0. And then we have, first of all coefficients are positive, it is tick. Okay, you can keep a tick mark for that. So all the coefficients are positive, right? All the coefficients are positive. But if you see, there is one missing term in between, that is s square. 4 is there, 3 is there, but square is missing. S square term is not there. And since s square is at odd degree or even degree? It is square, right? Square means it is even degree. That s square is even term. But what about other even terms? You see, s power 4 is an even term which is present. Even s power 0 is an even term, it is present. That means only one even term is missing in between. So it is not a Hurwitz, right? So if you observe in the first property of Hurwitz, all the coefficients should be positive. Okay, that is valid. It is satisfying. But there should not be any missing term in between. And if you see, there is a s square term is missing in between. So it is not Hurwitz, right? This is the first example. Then what about the second one? You see here, it is a 6th degree polynomial, s power 6 plus 5 s power 5 plus 4 s power 4 minus 3s cube plus 2s square plus s plus 3. So here also it is not satisfying the first property itself, that is all the coefficients should be positive for a Hurwitz, and here the s cube coefficient is negative, right? So because of this negative coefficient, that is minus 3, you can say that this polynomial is also not Hurwitz, right? This is also not Hurwitz, right? This is also not Hurwitz. Right. So like this you can even mention it, it is not Hurwitz. Okay, now let us check the third example. The polynomial is given as s power 4 plus s cube plus 5s square plus 3s plus 4. So here all the coefficients are positive, right? And there is no missing term in between the highest degree and the lowest degree. The lowest degree is of course s power 0, 0. Highest degree is s power 4. So there is no other degree term missing in between, right? So first property is satisfied. So now let us go back and see the second property. The roots of odd and even parts of polynomial p of s should lie on the j omega axis only. So this is the second one. What is the third one? Third one also says that if the polynomial p of s is either even or odd, the roots should lie on j omega axis. So these two are with respect to roots. Okay, but I told we don't need to determine the roots. But how to guarantee that these two properties are satisfied? So in order to check these two properties, we can check this one property, that is fourth one. That means if fourth one is satisfied, it indicates that these two are also satisfied. Okay, so in order to check 2 and 3, now directly go for checking of fourth property. So what is that? In order to verify the fourth property whether it is satisfied or not, we need to get the continued fraction expansion of the ratio of odd to even or even to odd, right? Anything is fine. Okay, before going for expansion, you need to know the ratio. What is the ratio? It is odd to even. Let us say it is odd to even. So for that you need to determine even part of the polynomial and odd part of the polynomial, right? So they are determined here like this. Okay, see, even part of the polynomial is, that means it is a part of the polynomial which contains only the even degree terms. That is nothing but even part. Similarly, what is odd part? Odd part is the one part of the polynomial which contains only odd degrees of that. Okay, so these two you can get from the original polynomial, right? These two are the ones we got, even part and odd part. So I'm indicating even with m of s, odd with n of s. Now we need to get the continued fraction expansion. This is the continued fraction expansion, and I'm doing that for m of s by n of s ratio. Anything is fine. Okay, let me consider even to the odd, right? Okay, so that means s power 4 plus 5 s square plus 4, we need to divide that with n of s. N of s is s cube plus 3s, that is odd part. Okay, now how to do this continued fraction expansion? With which term we need to multiply this to get s power 4 here? It is s. Okay, because we are trying to cancel out this first term. That should be the rule in the continued fraction expansion, right? So if you multiply with s, what do you get? You will get s power 4 plus 3s square. Okay, then these two will be cancelled. Then what do you get if you subtract? 2s square plus 4 minus 0 will be here, it is 4. Now it is continued fraction expansion. So now what do you get here? This will be coming to here now, right? Okay, now we need to divide this one with respect to this 2s square plus 4. Then how to cancel out this s cube now? If you multiply with 1 by 2s, right? This is very important. Okay, and like this we need to repeat till the time we get 0 at the end. Okay, once you get 0 here, what is the condition? All the quotients should be positive. All the quotients should be positive, right? So what do you mean by quotients here? These 4 are the quotients here. How many quotients are there? 1, 2, 3, 4. These are the quotients for this continued fraction expansion. So are they positive or not? Yes, all these 4 are positive. So you clearly write it like all the quotient terms are positive. So P of S is Hurwitz, right? So this is how you need to determine whether a given polynomial is Hurwitz or not, right? These 3 conditions are sufficient. Okay, once this 4 is satisfied, it means these two are also satisfied. Very important point. So the main properties that you need to check is that number 1 and number 4. If you are unable to get this fourth one satisfaction, you need to go for others. That we will see in the next class with other examples, right? That's it, right? Thank you.